When undertaking the process of coordinating multiple trades for your project, it is important to begin with a solid understanding of the project, its extents, and the quality of the information provided. We begin our multidiscipline coordination workflow by viewing and navigating the constructability model from our project. We leverage Autodesk Navisworks to do so, which offers construction professionals a comprehensive project review solution, providing advanced tools for interference analysis and spatial coordination. We can easily and quickly view the multidiscipline models to see if there are any obvious problems, then move into using analytical tools to find specific clashes. An important aspect of the Autodesk construction solution is not just the ability to find clashes and conflicts within our project, but to manage and ultimately resolve them. With this next phase of the workflow, we will explore Autodesk Navisworks' ability to quickly clash our models and to manage the information efficiently so we can reduce waste, requests for information, and change orders in the field. With the conflicts found, we will continue in Navisworks to manage the who and what part of the process to assign the conflicts found to the appropriate stakeholders. We will also take advantage of Autodesk Revit to ultimately make changes to the design in order to resolve the problems virtually before we get in the field, where conflicts and mistakes have the largest impact on projects' costs and schedules. The entire process can be tracked with powerful reporting tools that will ensure we have accurate and timely records of who did what, when they did it, and why. To that end, we will show how the Autodesk construction solution creates detailed reports of the conflict analysis, including the tracking of problems found through to resolution. Undertaking pre-construction coordination across all trades offers the best opportunity to understand constructability before work begins in the field, and to help avoid preventable RFIs and change orders that can risk project schedules and budget. Constructability models from each trade can be integrated into a single multidiscipline project model, regardless of authoring application. This is a key step to being able to coordinate these disciplines. By leveraging the constructability model, we can get a whole project view of the coordination issues at hand and begin to take steps to eliminate them by taking advantage of the work already done to create a model with construction intent. Here we can see that just a visual check shows there is a problem with the sprinkler system, and that we see part of the system outside of the building envelope. We can make a note of the problem that is shared with all project stakeholders and can be assigned to the appropriate party for resolution. The traditional coordination method involving overlaying 2D drawings on a light table is extremely time-consuming and unsurprisingly prone to many conflicts going undetected until encountered in the field. When you bring together design data that has largely been developed in isolation, issues can be expected. While coordination practices currently exist using 2D paper drawings, using a model-based approach enables a more efficient and robust digital process where you can visually see the issues. The project model can then be analyzed for cross-discipline interferences, be they conflicts with HVA systems and the steel structure, or adequate clearances around the fire protection sprinklers. Here we can see that a macro-level clashing of the systems and project components can be done. We can also follow our work breakdown structures and leverage the area and zone schemes established for executing the work. We see how issues can be visualized more clearly, reviewed in a collaborative way, and assigned for follow-up actions. Once a whole project view is understood, we can then move into a micro-level coordination, where we leverage detailed views of the model and get very specific on which elements are coordinated, and that the coordination is done in a logical and deliberate way, ensuring accuracy. As the issues are identified and managed, coordinating the needs and changes with the design or construction models are made easy with tools that group similar conflicts together, review in both 3D and 2D, and can switch between the single construction model and the originating design model. Here we see that we easily group clashes for one building component together, assign them to the appropriate stakeholder, and easily switch to the design application where the conflict can be resolved accordingly. This saves time in locating the conflicts and ultimately streamlines the workflow for resolving them. This enables easy communication of issues and synchronization of subsequent changes across the many team members and locations. Using the Autodesk construction solution and a model-based approach for coordination and analysis for multiple disciplines helps determine whether the various designs fit together and provides the opportunity to resolve any conflicts during the planning phases when there are no materials, equipment, or field labor costs involved.